Alright, so hopefully I have my issues fixed this time where there's not going to be a message sitting on the top corner, so apologies for that. So today I'm going to go over some of the issues that I ran into from the last time and how I kind of resolved them. So last time I was just creating a very simple basic WebSocket client, and now I'm going to actually use a real client that I wrote that will actually connect to the server, as well as set up the usual readers, writers, decoders, and whatnot. I also add this kind of like queue system, so I can just inside of my test push things into it, so I can queue up these messages. So once it does connect and it starts reading from the client, it'll basically dequeue a message and then run it, and then once it doesn't have any left, it'll basically disconnect. For the server changes, I went ahead and a couple of things. One, I was having an issue where I wasn't able to trigger the race condition or the race detector during the test, and it turns out it's because I wasn't also reading from it. So I created some more Go routines, and then I forced a read at the same time during this upgrade method, and lo and behold, the race detector started working. Other than that, other changes I made was, let's see, adding event types. I added another one for basically removing clients from the queue. So once they disconnect, it'll automatically delete them from the map, so I don't have any sort of dangling clients in there and taking up resources, as well as just some kind of debug test stuff just to make sure that I'm not leaking memory anywhere. So what I wanted to do is kind of cover some of the issues that I ran into, and one of the first interesting ones was when I was trying to do more than 1,000 clients, I ran into this funny issue that's specific to WSL v2 in Windows. If you do ulimit, and you can see I only have 4,096 file descriptors, and I tried to change that. You can't do it, you got to be sudoed or root or whatever. So I sudo to root, changed the etc, was it security limits.conf file. It still wasn't working, and it turns out you need to actually log in. So once you do log into your user, it basically kicks off something within WSL where then I can basically set my limits. So the limit now is 635. So from there, I basically am able to run my server and clients and have more than 4,996 file descriptors, which are of importance because that's what sockets use. So what I ended up doing was getting a client to send, where's the test? So I'm able to basically kick off 10,000 Go routines, create new clients, queue up 3 group created messages, and then once it connects, it'll basically fire off those messages. The server will basically process those and then spit us back responses from that. So I'm testing bidirectional communication here with 10,000 clients. So if we run it real quick, you'll see that it just has no problem connecting. It would error out or crash or whatever if I had any errors here. And then once the test is done, it should then fire off the disconnect, which will close the socket and then kick off the removing them from the queue. So while that's pretty good and the memory usage isn't too bad, if we go to the server, go to htop real quick, we can see it's taking about 200 megs of memory, which isn't, I mean, it could be better, but I'm not too concerned with that yet. Only thing that I kind of see as being a problem is, and again, I'm running this from WSL v2, so there's 10,000 clients and then 10,000 clients on the server side. So I noticed the CPU is going a little bit crazy. You can see that it's pegging all 4 of my cores here. So that's definitely something to keep an eye on, but I'm suspecting because it's, just this all of a sudden burst of activity that causes it to basically spike the CPU. So I wanted to kind of figure out where this was coming from. So what I ended up doing was using pprof, which is Go has some amazing built-in tooling for this. There's 2 ways or 3 ways I'm running this. One is running the interactive server as the Go process is running. You can basically listen, make sure you import the net HTTP pprof. You can listen and it'll basically, you open a browser and you can get all the active Go routines, and I'll demonstrate in a second here. The other one is just creating the CPU and memory profile files. So if those flags are set, I'm basically creating the profile for it. And then once the process exits out, it'll spit out the file. So you start up the CPU profiler, you run your code. In this case, I'm running my server here. And then, yeah, the server's here, handling a interrupt. So if I hit Control-C, it should send a signal notifying that it's done. It'll shut down. Then it creates the memory profile and then exits the process. So if we run this with, let's see, was it, I already forgot, CPU, let's do both, CPU, cpu.pprof, and mem.pprof. So we're going to run it like that, and then we're going to run our test client. I should probably add a log file here. Run the test client, wait for them to disconnect. Come on. All right, they're all removed. GC triggers, so we're good. Shut down. Now you'll notice that there's two files, the pprof or the mem and the CPU one. So then Go has this tooling. Go, not Goo, tool. Oh, I messed up my backup. Control-R, Go tool. pprof. Why is it? Wow, Control-R is not working. All right, Go tool, pprof, and I forget I think it's HTTP. Yep, HTTP. And then let's do CPU. Whoa, no profile. Oh, that's weird. Do I need to pass it a profile? That's weird. 1 second as I remember what. I'm going to try this again with Control-R. Let's do HTTP. Okay, whatever. So it's Go tool HTTP. Oh, I never gave it an address. That's why that didn't work. And then the profile. So this is the CPU profile, and I'll zoom in here. So you see that most of the time was spent in the network loop, which kind of makes sense. That's where it's processing most of the information. WSL, that calls down into the WebSocket next frames, which is reading the header. Yeah, and it kind of goes down from there. You see a lot of activity here in the netFD read, so it's reading information from the socket as well as polling for it. And then most of the time here is just ending up in syscalls, which I imagine it's doing all the network I/O stuff here. So, which is good because I'm not seeing anything of my code that's too red. The darker these are, the kind of more time you're spending. You can see a little bit in listen, send message is spending some time. We can also go to flame graphs, so we can see, oh, why is this so small? Make it real big. So again, we'll see that most of the time is being spent in the these reads for the socket, which again, I'm kind of happy to see that and not in my code. We can also peek at the kind of various information of where the syscalls. You'll see this get random, and I was like, I don't remember I'm using random, but then I realized that I'm using UUID, generating new client UUIDs. So this is going to take up a little bit of time, but again, not too much. But yeah, again, most is in syscall. Vuetex was interesting because I'm not really using blocks, but I imagine this has something to do with the Go routines and scheduler and all that. So that's pretty interesting for the CPU stuff. For memory, if we do mem.profile, we can see that, what is this, sample allocated objects. Is that what I want? Allocated space. I'm kind of curious about space. How much is stuff taken here? So the upgrade was taking about a meg of 85. Buff.io is reader, because it obviously needs to allocate for reading from the sockets. This one's kind of interesting, the new cipher reader. I think this is reading the sec key or whatever it is for WebSockets. New group created, so I'm creating 10,000 of these, or no, yeah, 10,000 or more. Yeah, I think I'm creating it for every single message the client sends to me, so I'm creating one of these, so that's going to be a lot of objects being created there. And there's probably optimizations I could do there at some point, but yeah, not too worried about it yet. Long story short, I don't feel too bad about this implementation so far. I can have 10,000 concurrent connections, sending 3 messages and receiving 3 messages without any errors, any socket errors. So that's always a good sign. So that's pretty much where I'm at for this. One last thing I want to demonstrate is using the built-in pprof server. So if we run this with, I just did this. How do I already forget? Go to main. Prof. Okay. So now we have our server listening on 6060. Should be here. Debug pprof, or is it pprof? Nope, it's debug. Okay. So in this case, we can see allocations that have already happened. Regex compile. What's doing that? Oh, maybe it's the HTTP muxer for matching. I don't know. But yeah, a lot of good memory stats here if you're ever curious what your memory is while you're running. Go routines, you can see we already have 9 go routines. So we have signal loops, the main go routine. We have our internal pull waits for the network stuff, HTTP server, as well as chan server listen. Matchmaker spins up a checking queue kind of ticker, so that's going to run on its go routine. And again, nothing out of the ordinary here. You can also do kind of snapshots of like CPU if you go to like, I think it's, if you just do heap. Nope, not heap. I thought it was like CPU or something. Oh, here we go. Go routine stacked. Nope. Sampling. Yeah, I think if you just do like heap, yep, it downloads a pprof file that you can load into that tool that I just showed earlier. But we don't need to do that because I already did that. So we're going to kick off the clients real quick, and then we'll switch back. So if we refresh this, you can see I have 10,000 go routines handling all the clients. And it's just, yeah, I think it batches them up, so you should actually see 477 there when this snapshot was taken. It already exited out, so, but let's take a look at allocations. I believe this is the bytes. I forget exactly. Once I went through the profiler's code just to make sure I knew what all these numbers were, and I wrote it down in a gist somewhere or whatever, or a note somewhere. I'll probably have to bring these back up. But yeah, again, nothing too crazy. I'm pretty happy with the performance so far. So, although it's not really doing anything, so that's not a great indicator yet. But one other thing that I wanted to kind of think of was, okay, let's say 10,000 was literally my max limit. How could I get more clients to connect? One kind of idea that I had was to have like a so you'd have a forward proxy, like maybe Nginx. Oh my god, I'm so bad at that. Oh my god, I can't do this. Nginx, whatever. Yeah, you know what it is. So Nginx in the front. You can do load balancing and backend proxy pass. So you could proxy all of these going out to different game servers, basically. The only thing that I hadn't really, oh my god, this is, I need to get a Wacom tablet or whatever. Yeah, oh my god, I can't even write an S. This is embarrassing. Okay, so you'd have the proxy, all the clients coming into it, obviously. So one issue is this is, okay, what if one client was here, one client was here, and one client was here, and they wanted to create a group. The only thing I could really think of is either not using Nginx and using a custom proxy and basically hijacking the connection and redirecting it up to the backend server, or basically forcing the client to disconnect and then reconnect and then somehow forward them to the correct one. So maybe use some sort of header token that Nginx could talk to. But I think Nginx might not be too good for this because I feel like I would need more custom logic for redirecting users. And the library that I'm using today, yeah. They actually have, do they have their examples? Yes. So inside of their examples, they have a proxy. So you can see bigger. Basically what they're doing is the handler creates a new connection, and then it basically hijacks. And then from those hijack connections, they basically just copy from inputs to outputs. So what you could do here is when you're doing the connection, I don't know if you can read the data from it first. You might have to read the data like to get the headers to know which backend to redirect to, but that's definitely an option, I think. So that's pretty much what I'm thinking. And then all the state will be in Redis anyways, so there shouldn't be too many issues with passing that type of information, because they're all going to be reading from a Redis backend. So that's pretty much where I'm going with this. And if we can go back to the code. So yeah, one other kind of interesting potential optimization is for the JSON library. So I found that the way that I'm reading JSON here, which is in, I think it's both of them. Where's the decoding done? Send message. This is the encoding. Decoding would be done. Process client message. Oh, I disabled that for now. The server. Let's just look at the client then. Yeah, so the way that I'm decoding the network message here is, again, it has the network message type and then it has the data. So I'm pretty much decoding twice, which is not optimal. I mean, you'd probably not want to use JSON to begin with, but if you had to, this is kind of the way to do it, so you don't have to have different data types for each one. You can just kind of nest it inside. Now, JSON raw message, apparently the built-in JSON decoder is not optimized it, and it does this like decoding compaction twice, and I found a ticket for it. They said that it's too much of an optimization, they're not going to bother fixing it. So there's other JSON libraries out there, such as JSON Iter, Easy JSON. They have very high performance. So, I mean, if I start to run into issues, I will probably switch to one of those. But for now, I really just don't care. I think 10,000 clients is sufficient for my testing. Because, I mean, at the end of the day, most indie games, I think it's like 1% actually succeeds. So the chance of this actually turning into something is, let's be honest, is pretty low. I'm not kidding myself here. But hey, I'm learning. That's all I care about. So we have our network messages. We have our decent server. We have a decent game client that we can test things with and queue up messages. So really what we're looking for is to start actually building out some of this logic. And I think the best place to start is with the server. So first things first, I don't like these kind of hard-coded numbers, so I'm going to make a server event, basically like an enum. Server, oh, you know, I just realized I didn't start this. So now you can see what I'm actually typing if you can't see small stuff. And I just messed up. All right, server event, go. Package server. Type server event. I don't think I'm going to have many, so I'm just going to make an 8. And we're going to define some thingies here. So, where's my server? Chancer. So 0 is client added, so client connected event. And that is a server event. And we're going to set iota, so we'll start from 0 and increment up. And then we have, and I can already switch this over to a server event. And something should probably complain. Nope, it doesn't. Still accepts that. Okay, so client connect event. We are going to have a client message event and a client disconnected event. There's also going to be a client reconnected event, which is something interesting to think about. If you've ever played a online game and you're in the middle of a match and you get disconnected, it's like, okay, how do they know to reconnect you to the game or the match you're in? Hopefully they did that. If they don't, it's really irritating. But what I was thinking of doing for that is to delete it from the active clients map, add it to a disconnected clients map, basically the same thing. Again, the maps are going to be replaced by Redis, but whatever. So they'll be in this disconnected map or queue or whatever you want to call it. And then there'll be probably another Go routine that reads from that to see if it needs to basically time it out and remove it. So maybe give them, I don't know, a minute, maybe 3 minutes, because matches are going to be probably anywhere from 10 to 20 minutes long. I think 10 to 20% of the match time disconnected. Oh, and if someone does get disconnected, then you have to think about, okay, what happens to the disconnected player during that time? Do you take it over with an AI bot? Or what I'm thinking of doing is giving control of your character to your teammate, because it's turn-based. I can do a lot of cool, neat cheats that you can't do with a real-time MOBA or a real-time matched game. So I think I'm going to lean towards, or maybe even give the option, say, do you want to player disconnected? Do you want to take control of this player? Yes or no? And then we'll set up the whole controller stuff later to give ownership. But getting ahead of ourselves here, what if a client disconnects and reconnects? So again, put them into their own map. Once they're in that map, have that Go routine, iterate, make sure they don't need to remove them or purge it from them. Now, if they do reconnect, instead of going into the client connect event first, well, it will go to the client connect event. It should test to see if it's in, what am I even talking? I'm just going to do it right now. Clients, and we're going to have disconnected clients. And we got to make it. Am I not making clients? Oh, there it is. That's poor visualization. Disconnected clients, make map string, change client. Okay, we got our disconnected clients now. So we're going to, let's make this a method. Yes, change server was client disconnected. And then we need the client ID. Actually, let's take the client object. There will be probably, again, the state will be coming from Redis, so we should have the ID, the authentication. Once it reconnects, it'll have to re-authenticate anyways with a token or ID or whatever it's using. So we should have the same ID across disconnects. We don't have it here because I'm literally generating them as I create them. Again, these would be generated, stored in a Postgres accounts database, and then passed along once the user is authenticated. But for now, we're going to cheat. Okay, so we have our was client disconnected. And then I guess we need to keep the same data except for the net connection. So the actual WebSocket will need to change, but everything else should be the same. All right, so was the client disconnected? And then we're going to return a chain client again, which is kind of weird. Maybe I'll do a nil check, or maybe I'll do a bool, and no, bool should be Idiomatic go here. So we don't need to lock yet because it's all access from a single Go routine. So s disconnected clients, clients ID not exist, and we're going to do clients exist. If not exist, then we're going to return nil and false. And if they are legit, I kind of want to do a nil check too. Yep, I'm going to do a nil check. If not exist or client equals nil. I don't think that'll happen, but you never know. Return client true. So now we do our. All right, so I'm already doing a nil check there. Reconnected client was disconnected is equal to the method I just made, which was called disconnected client. I don't know, was this client disconnected? We're going to pass in the eClient. And if it wasn't, I don't really like, all right, well, if it was disconnected, if it wasn't disconnected, you know what? No, I don't want to do that. Okay. I was going to just add the reconnected client. Actually, you know what? I could do that. That'd probably simplify things. Yeah, you know what? I'm going to do that. We are going to just return the client. Oh, wait. Oh, bad naming. Disconnected client. Right, so we have the disconnected client. If that is equal to nil, then return that. Also, I did not replace netcon. And then do that. This way, I don't need to worry about. Actually, I don't even care if it was a bool. I can just remove that. But I'm definitely going to make a note of this. Was client disconnected? In the event the client is reconnecting, return the disconnected client. Object is the net.con replaced with the new website. Else return was client object. That's what I call it. Right. So now we don't, and I don't like the was terminology because that makes it seem like a Boolean check. Maybe replace. Yeah. Replace disconnected client. Why won't it let me? All right. Replace. I don't like that word either. But hey. Can always refactor. Then I don't need to do a check at all, and I can just do this. And ooh, I'm just gonna make this client, just so it's easier. Client, client, client. Get rid of that, and get rid of that. Right, so they connect, check if they're replaced, or replace if they are disconnected and reconnected, put them back into the client map, and then send a message. Yeah, obviously this is debug. Cool, so client connect event, and then we have the disconnected. All right, that's past tense, that is not. So let's make this client messaged, client message received. Yeah. Whoa, don't care, go away. Right, so then we have the client message received event, and we have the disconnected. Now, the event that comes from the clients or whatever, I would probably want to, I'm probably going to want to add a field, for reason of disconnect. Because if they quit, I should be able to get that information and then not do this reconnected dance. Or even if they're not in game, I wouldn't have to do this. So I should have more information at the time of the disconnect. So yeah, I'll add a field for that so I know what I'm doing later on. Okay, replace netcon. Oh. Actually, would that even be an event? Because they're just going to be connected. Also, I did not delete it. Right, so if they are disconnected client, I need to delete them. Otherwise, that would get stuck. Delete. Yes, disconnected clients. Disconnected client. ID. Right, so then they're removed from that map, so I don't have any leak there. And again, there will be a Go routine that monitors this map to make sure if it needs to remove stuff or not. Okay, and then replace net connection. So I don't think Chan client has a right, so if they are reconnected, there's some interesting stuff with the connection because it's creating. Okay, we need to do this. Func chan client and no reconnect because it has to do a bunch of stuff, not just replace the net connection. So we need the new netcon con. That is a netcon, right? That's the initial. Yes, it is. Okay, so we have the netcon coming in. We need to recreate all this stuff. And you know what? I can just do handle connect here. And I can reuse this code. Ooh, does not like that. You know what? Yeah, screw, don't repeat yourself. I'm going to repeat myself because I don't care right now. Okay, so get all that stuff and then replace. Actually, I can just do this. Oh, okay, yeah, so I can do this. Okay, c.reader, c.writer, decoder, encoder, and I can actually. Yep. So I'm going to just delete this, and then I'm going to do c dot handle connects with the connection. So when the new client's created, it'll call that, and when the reconnect event occurs, it'll call this as well with the connection, and then we're good to go. Provided I didn't miss anything. I did. I forgot to do the connection. C.con. Alright, just gonna make sure I don't have any like messages popped up on my thing here. Cool, nice. Alright. So we have to get rid of that, handle connection, and then start the network loop. And this should also be here because on the reconnect, it'll need to re-kick that off because that go routine should have exited once the client was disconnected, because the reader next frame will fail, cause an error, breakout. It'll send the disconnected event, and then it exits this go routine. So we have to kick it off from here. So if they were in a disconnected client state, would want to force that that go routine to kick off a new one. I'm sure there's bugs in this. We will test this at a later date. Handle connect and reconnect. Right. So replace disconnected. In this case, we need to. Wait a minute. Is this right? If it doesn't exist, where the client disconnected is nil. I'm an idiot. We're deleting it if it's not there. This, let's call it, yeah, let's keep it client. Here we delete it from the disconnected clients, and then we take the disconnected client and handle connect client.con. I should, it's not an interface yet, but I'm probably going to change this to an interface, so I'm just going to do that, and then go to the connection and do this. Client connection, return connect.con, and then return c.con. So that, again, when I make a interface, all these will need to be exportable methods. So that's why you see me using the uppercase stuff instead of the lower property names. Right, so handles reconnect. Don't have any air conditioners there. Returns the disconnected client. Let's call this reconnected client. As you can see, I care about my names way too much. Reconnected client. Yeah. Okay. Cool. So, client disconnected, deletes it from the map, but we want to add it to the drum roll. Disconnected clients, clients ID is equal to I should kind of want to set a flag saying it's like dead or disconnected, but I think it's kind of obvious since it's in the disconnected clients map that it is. But whatever, we'll add tests and stuff later. Cool. All right, so what else does the server need to do? Handles the connect, handles the message received. All the other subcomponents and systems are going to be the ones doing the actual message sending. So I don't think I need to worry about that. I think just the disconnected and reconnect. Again, I might not need this, but whatever, we'll leave it there for now. And hold on, because I am freezing. Yeah. Alright. Got my hoodie on. Life is good. Okay. So, disconnected. We're good there. Chan client. Is there anything we need to do for the client? I don't think so. I mean, they're pretty dumb. They just send messages by encoding them, send the events if they receive them to the server processes them. So the main question is, what does the server do when it receives an event or a message? And it is going to process that. And this is where you need to start to think about what type of messages you're going to have and what type of data they need and who cares about the message, because there's so many different components. You have the matchmaker component, the team component, the group, team or group, depending on what I decide to do for that. You have the world, you have controllers, levels, characters. Yeah, well, when they select characters, we have to change their state. For now, I'm just going to do a super big loop. Yeah, switch. I was going to switch and select myself. Message.type case, and then that is of a. All right, so we have group messages. Oh, right. So I'm going to probably group these up by types. So then I'll have like a chan server, process group message, and then client chan clients, and then I'll need the actual, I'll need to know the type. Oh, right. Right. Actually, you know what? I think I can just do data JSON.raw message again, I will probably change all this eventually. All right, so if we get a group message type, we are going to process the group message with the client and the message data type, right? And then if we have a message of, that's weird, accept invite, whatever, still yeah. So we have group messages, maybe character messages. Like if they select a character, deselect a character, then I'm going to have other types, character, message, data. Just copy this. And process character message. Anyways, we're only going to focus on the groups to start, so you know what? Why write more code if I'm just going to delete it? Which I'm totally going to do. Okay. So let's think about group messages. So when a client connects, they have, oh, I just got a question. So what game are you making the server for? This is going to be a, I don't want to say clone, but for a game called Atlas Reactor that was a turn-based MOBA, basically, where you would have 4v4 characters and your team, you basically have 4 stages. And actually I can run through this real quick again, just for anybody else who's joining for the first time. So the game works in 4 states, where you have a dash state where you basically can evade or gap close. Then you have the fight state where you shoot each other in this like kind of, it's basically a 2D grid or an array. And then you have a move state where after you shoot, you can then move, run away, follow someone or whatever. And then it goes back to the decision state. So you have 20 seconds or whatever to decide what you're going to do. So it's a very tactical, think kind of like XCOM, but mixed with a MOBA. It was a very interesting game. Tryon killed it, I don't know, 2 or 3 years ago. And I've just been itching to play something similar. So I figured I'll just make my own, and worst case scenario, no one plays it, and I just create AI and I play myself. So that's basically what the deal is. If they're even still connected, I don't even know. I don't know this streaming stuff yet. I'm still learning. Yeah. So back to clients, processing clients. So care about groups. And I created, I think I might, there we go. People who are not familiar, I'm using mermaid charts here. They're super easy to just like knock out these really nice diagrams. So if you're ever not wanting to use Visio or whatever those weird graph systems are, definitely check out Mermaid. Okay, so I have the kind of flow for groups. Actually, I'm going to make this bigger because I don't know how well this looks on the stream. So we have a number of different kind of states or actions that can take. We're looking at 1v1 right now, where again, one character would control 3 different characters. So you'd have your healer, your tank, and your damage class or whatever, which are going to be geometrical shapes because I suck at art. But yeah, so in 1v1, you'll control all 3. You'll be given allotted extra time for each stage of the game. And then you can basically do your movements and do your actions of firing or whatever. But there's a number of things that we need to do for creating just a group, which is the leader. So the leader is going to create the group. It's just going to be you. So the flow is much easier. We just connect, we create a group that creates a group object, which is going to assign us a group ID, which then the server tells back to us. So they say, okay, you're the leader. And then there's the case of where you destroy the group or you leave the group. So you'd basically send a destroy group message with the player ID. The group would get destroyed and then basically communicate back to you that you're removed. And then it would tell the server, I'm still not sure about this, but I think the server is going to have a map of groups, or actually Redis again. I keep thinking in terms of Go stuff, but the state will contain groups, and it'll say, remove this from the data store. Then you have a select character. In this case, it'll be select characters. So you'll need to send a select character event when you select it, which then goes to the group, because the group needs to track of making sure that all 3 characters are selected before it allows you to play the game. So character lock-in will probably auto-queue for a 1v1 game, because once you lock that last character, it's probably going to say, okay, you're ready to go. Or maybe I'll have a button, I don't know. So then it sets the ready flag, and then, yeah, it should be grouped, and then I haven't added the state yet, but added into the matchmaker's queue system as a potential candidate for a match. The 3v3 is a little bit more complicated, where you have to, I zoomed all the way down. So the leader will create a group. They'll be given a group ID, and then they will send invites to players. If the player joins, or the server needs to send a do you want to join, basically a join request. If it accepts it, then it adds the player ID and the group ID. I'm still a little bit worried about passing this type of state directly to a client, but we'll see how it goes. And then the server says, hey, player 1 joined to the leader. So it's going to broadcast back to the original leader that they joined, and they're ready to go. So if you leave group or disconnected, there's a couple of other states. If it's a player and they leave the group, removes the player, tells the player that they're removed if they're still connected or not, and then tells the leader that they got removed, and then it sets the not ready states so that, yeah, it wouldn't be able to queue. Or if it was in queue, every time the matchmaker ticked, it would say, whoa, this group's not ready, and bump them out of it before processing them, which I need to add that. But anyways. Now, what happens if a leader leaves the group? And it's funny, like when I was writing this, I'm like, holy crap, online games are not easy. There's so many things you got to think about. I was not prepared for this, but it's been fun and interesting. So, right, so leader leaves a group, removes a player. Basically, the server needs to notify all the players that the player was removed, unset the ready, and then I think I'm just going to elect a new leader, so I'll just bump to the next person who's in the team, and then notify the other player that this other person is now the leader. And I just realized I need to have an elect leader option. Maybe I don't care. Whatever. Destroy group. The leader can destroy a group. So they will basically say, hey, I want to destroy my group. And if they are the leader, then yes. And then it just tells the player that they were removed, and then destroys it. Then we have select character state, where you have to basically, you select your character, and then basically broadcast to everybody else that you selected your character so you can see what your teammate has chosen. And then the same thing for the other players. And then once everybody is selected, I don't think I added it. There will be a ready flag here. Wish I could just have that. What does it look like? Set not ready. Whoa. Set ready. So that would be, yep, player 1's character selected. So at this point, we would have a group is saying that the set ready flag. So they would be ready to queue at this point. And I might need to have another message saying, although I guess the leader would know that they have all of the characters selected, so they would be able to, yeah, they would know, and they could say, okay, we're ready to go. Oh wait, no, sorry, I have a lock-in state. Get rid of this. Oh wait, no, that's the wrong one. Which one am I on? Yeah, character lock-in. Once they're locked in, then we can set the state. Don't want to lock it, set them ready when they're not locked in. That would be really irritating. And then what happens if two users try to choose the same character? And I'm thinking of actually restricting to role-based, so there has to be one healer, there has to be one tank, and there has to be one damage class, which I know it's not great, but I don't know. I mean, this is once I get to the playtesting part, I'll play around with different styles. But for now, I'm gonna assume there's roles, and I'm gonna assume that you have to have one of each role filled to be able to play a game. But yeah, so if a character chooses one that's already selected, it basically it's all the checking's done server side to make sure that no one tries any funny business. And then, yeah, it basically says, hey, this character is already locked. I think that's it. Yeah, character locked. Character taken, yeah, so it'll send a message saying this character is not valid, so you're not allowed to. And then they'll have to choose a new one. So that's pretty much, I'm sure there's going to be more states, but these are the states that I can think of off the top of my head. Yeah, it is the typical mix, tankular DPS, which, I mean, I'm not, again, I'm going to have to get to the playtesting state. The first stage is to make sure I can actually get the game up and running and the world defined, and then I can go play with different play styles, which is really a good thing about doing everything server side first is you can create all the play logic much easier than you can if you have to go into Unreal Engine and define everything and write all the blueprints or all the C++ classes. If you do everything on the server, you can create really crappy, in this case I'm using WebSocket, so I'm just going to create a crappy web page where I can play the game and see how it kind of feels before I get to the point where I'm putting stuff in UE4 and defining all of the kind of the graphical stuff. So yeah, I think that's the route I'm going to go. So let's see, where was I? Right, groups. We have our groups. We have our disconnected stuff. We are now processing group messages. So the first one, and this is the server. So character, let's go to 1v1 first. 1v1. First, create a group. So they need to basically probably click a button saying, I want to play, which will send a create group message. Let me just memorize this so I don't have to look at it again for a bit. All right, create group, create group ID, group ID. Okay, so create group message. So if we go to our messages, group message, there needs to be the group created. Ah, Jesus, stop doing that. Group created. I guess that could come from the client. It's kind of weird because it should be like group create request. Let's try this. Group create requested. Put everything past tense here. Group created. That should work. So this group message is going to have an event type, which is one of these. So again, I'm decoding depending on what it sees, which since it's JSON, it's going to emit it anyway, so I don't have to worry about any like unnecessary data being there. Although I guess for allocations it would matter because it's going to allocate all of these objects every time. Again, JSON's not going to be the final one, so I shouldn't worry about this. Okay, so new group created. No, because it's going to process the message. Oh, also I need to make a data structure for my groups. Map. Groups. Map. String. Do I have a group? Did I already write this code? I don't even remember. I did. Okay, so a group has an ID, group size, leader ID, the players. I actually don't think I need the mutex anymore because I switched to a single go routine for accessing. Boop. I can always add it back later. Yep, don't need to lock them anymore. I'm a little worried about removing that lock. No, I'll keep the lock. Why not? All right, so a new group is created with an owner with a group size, creates an ID, gets the leader ID, the group size, you add a player to it. If If it's a 1v1, then you do not add players to it. Destroy group, select character, remove player. This new player remove, that should be whatever, I'll move that later. And elect new leader. Okay, so where was I? We need a group create requested. So let's make a new one. Okay. New, great. So it's going to be coming from the client to the server, so we're going to have to get we're going to have, we decode it. Oh, we don't need to create a new routine for that because it's coming from the client, because it's just going to get decoded. Although the client will, my testing client, you know, I'll just add one anyways. Yeah, of course. Yep. New group created request size integer, return a network message, because I'm going to basically do this dance. So we have the group type message, we have the event, which is group create requested, we have the size, we have Marshall, the data, and then we stuff it into a network message, which has the type of group message type, and then data. So again, this is going to be coming, let's make a note of it so we don't forget, from client. So if we look at our client, they would be the ones sending this message saying, hey, I want to create a group. And I'll create tests for this in a second just to make sure everything works. So new group create requested comes into the server. Let's pick that up. I didn't make it. Oops. Make no string group. Don't think that's going to be an interface, but I'm going to change it later. We'll see. Yeah, that was just for testing. Don't need to do that anymore. So they connect, send the event, send the client process, client message. That goes to a group message type. We're going to process it there because this is probably going to get big. I don't want to do everything inside this one little switch statement. They are going to take the data and they know how to decode it. So JSON on Marshall, the data. Nope, I need to actually define what it is. Oh, damn. Oh, it's a group message. Oh. Group message is equal to a pointer struct. So we're going to unmarshal that data to the group message. All right, and this is in the messages package. Message package. Do a little error check. I don't know what I'm going to do with errors yet. I'll do the easy thing. Just log them. Right, so we log that message coming in. If there's an error, oh no, definitely going to return. Pretend it never happened. Usually you'd probably send something back to client. I mean, if that should not fail. Oh no, I guess it could because it's coming from a client. So yeah, definitely want to check. Cool. So we have our group message. And again, this is coming from the client, so we can't trust any of this data, like at all. Gotta be super careful with this stuff. So we get a group message. We now have to switch on the type. Group message type, event, and then case group. Oh man, it's so hard to wrap your head if you're working on the client of the server. Like, where is this coming from? Because it's like the client, but the clients of the server or whatever, not the web, not the actual agent that you're connecting in. Yeah, whatever. Anyways, does my head in. So group create requested. So what this is going to do is take in the... Do I need to check if the user's already in a group? I do. And I don't have a flag for that. Oh, that's interesting. Oh, dang. Because if they're already in a group, all I have is group IDs in clients. The cheap way is to set a flag on the client or set a property, but I don't want to bloat this because, again, if you have 10,000 of them, or 20,000 or whatever, I think for now I'm going to, just to keep moving here, group ID string. I'm definitely going to have to change this, but for now, I will just check that. No, I'm trying to make it a C chain client group ID returns group ID. Just read messages real quick here. Yep, it definitely gets complicated fast, and yeah, there's so many sanity security checks. I totally agree with that. So for those who don't know me, I am a security researcher as my real job. This is just for funds. So yeah, I definitely know the importance of validating user input and not trusting clients whatsoever. So anyways, so I'm just going to say returns group ID if and only if is in group. Oh man, this feels like a getter setter and I don't like it, but whatever. Because we also have to set the group ID at some point. Yeah, again, just moving along here. So, all right, got that done. Group ID, go back to the, it's not going back to the server. Groups. So we are going to basically check if clients dot group ID is not equal, and again, this will all change. But it's good to get the logic of what you want to do in before you go too far. And also when you translate and actually update, you want to be like, oh yeah, I thought about this case, so now I can change it later on. Yeah, so client group ID does not equal, that means we're going to return. Again, we'd probably send error here, but let's just make this a macro. Send something back to the client. Why are you trying to create a group again, dude? Otherwise, we are going to create a new group. And the owner is the client. And did I ever decode this message? Yes, I did. Okay. So that needs a size. So that will be, oh, you know what? I didn't add validation here either. I'm going to go validator. I don't remember the package code. Validator. Oh, that is definitely not the right page. Go playground. Is this the one? If it's version 10 or something, then this is probably the right one. Yep, that's the one. Okay. Right, so validators, I've used it before for CRUD apps and stuff, but basic, yeah, look at that, it's right up to V10. Alright, so we're going to grab that for our module. While it's downloading that, I need to refresh my memory how to actually use the struct tags. Like I want like min-max. Oh, dude, just give me like an example struct with all of the flags so I can just cherry pick what I need here. Examples. I don't need custom, I need like simple. There we go. So I can't do required because I want them to be omitted if I'm not getting that type of message. So I'm going to do validate. Oh my god, it doesn't have min, does it? Huh. Alright, I'm pretty sure it's just validate. Oh. I think it goes like this for struct tags. I'm pretty sure the ID will tell me if it's messed up. Struct failed tag not compatible. Key value pairs not separated. Is that what you want? By spaces. There we go. God, IDs are great. So we want. Oh, we do not care about hash to the wrong one. I mean, we do. We will validate that at some point, but right now we need the size is between. Actually, no, it's one of 1 or 3. 1 or 3. I think that's how the one of works. Don't remember. One of. Okay, let's try to find a better one. Map validation. It's probably not what I want either. Ooh, min-max, that's good. Need that eventually. Come on. One of. Alright. I mean, I know the basic flow now, so if I go back to that page, I should be able to find it. One of. Good lord. I'm pretty sure it's just that. But yeah, I will add. No, I should do it now before I forget. So, group message. I hope this triggers only if it has a value. If it triggers, if it's empty, that's going to be stupid. But I don't think it does. I don't think it does. I hope it does. Okay. So when we go to decode, we need to validate. And I think we need to like import a validator. Let's go back to that simple example. Oh. Select validator. There it is. Use a single instance of validated. It caches struct info. I mean, I could add this to the message. I'll probably move this, but for now I'm just going to put it here. In fact, I'll probably move all the decoding stuff into its own. What's that? V10. V10. Thank you. Do I need to make a new one? Yes, I do. So validate.new. Ah, this is so ugly. I don't want to do this here. Ah, whatever. Just doing it. Yeah, validate equal to validator.new. Oh, no, that's nasty. I'm just going to make it a property. And then we'll just do it here. Right, so we have our validator. We are then going to validate our process group message. S.validator .validate. I thought it was just validate. Validate map. Bar with value. Good lord, this is not. struct. And that's pretty straightforward. Struct of group message. So if you get an error here, the usual song and dance. Now I would like to actually, I've been writing too much code and not enough tests. I need to write a test here soon, but owner, group size. All right. We can be sure, or at least somewhat sure, that the size should be correct. So we will take the group message.size here. Oh, right, I am using an interface for client, which is not fine. I didn't update it. So I need to make an update to that client. So the game client interface needs to have all these, and my current one is missing which. You know what? I'm gonna cheat. Just add them all and see which ones it says are duplicated. Shift, was it Alt Shift I? There we go. Func. Is this chain client? C, chain client, ID. Boom. Alright, so we already have a character. Send message. Oh wait, no. That's, hold on. It just didn't have a reference to it. Game dot. Game. That one already exists. Okay, we're just going to return connected, I guess, for now. Again, we'll update all these later. This is just going to be, I don't want to pull in the mod package, it's going to break everything. We'll just return a player stats. This will need to get updated as well. State, right? So when character state changes, I want to keep a track of when those happen, especially for dealing with disconnected states, timeouts, how long they've been in queue, all these things I want to kind of track. I mean, I guess queue stuff will be handled by the matchmaker and group, but yeah, it's always good to have a time series of when someone or something entered a state, so you can check to see if it needs to time out or whatever, right? So set character, character ID is equal to character ID, game character, and have not even defined what that is yet. Whoa, what am I doing here? Set character. Let's just return now. Send message, I already have that. Character, return c.character. I don't have a character yet. Do I give I'm going to return now because I don't have characters yet. Okay, we should have everything, and I'm going to add connection .con and handle connect to the interface definition here, and group ID. Ugh. I already don't like how big this client interface is getting. There's whatever. Code can change. Jesus, I am already over time. I'm going to do probably another 5 minutes and kind of wrap it up here. Yeah, I got my character. Group ID, decide a func string, what func. Oh. cool, I got my group, and then I can do s.groups group.id is equal to group. And that should do it for this. And the client is giving me an error for some reason. Oh, this is my old one where I was just going to have all the clients in Go routines, and I had all these locks, and it was just nasty. Like, so the network loop would run in a Go routine, but then they would all do that, and then they had a reference to the server, and they were just going to like blast out messages, which was awful because I would have to have locks on everything, and it would be very complicated and hard to debug. But so what I did is I basically said, no, the client gets a reader Go routine, and then from that reader Go routine, they basically send a channel event message. That's why it's called the chan client right here. So the server will get that event, and then that no longer runs. That's it for that Go routine. It doesn't leak any of the Go routine's actions outside of this network loop. So that way it can be guaranteed that the server is only processing everything in the same Go routine as long as I want it to. There might be times I'll need to spread it out, the load, if there's too much contention. But again, I got 10,000 clients, so on this like crappy VM inside of Windows, inside of the Unix subsystem. So I think it should be okay for what I'm going for. So we'll see. But yeah, I'm just going to delete this because that was garbage code. And nothing feels better than deleting code. Yeah, right. So process group message, validate it, then make sure the event type, create the group, add it to the groups, and I'll do the whole stuff later. But one thing I want to do before I go is actually write a test. And I think I'm going to cheat, and I just want to test the. First off, I want to rename this to server. Do I still have an old server? Yeah, con server. No, that was an interface. All right, I'm just going to rename this to server. Ooh, I already have server. What? Oh. Yeah, this is the old one. Again, where there's like locks on everything. Oh, don't tell me. Okay, I didn't know. The bad thing about leaving old code is sometimes you accidentally write to the old code, and then you get mixed up which changes you made to which file. Anyways, we're fine. Server. Server.go. We can hopefully... Oh, that's going to piss that off too. Mock teams. Oh. So I usually do for mocking, I just create structs that match the interface. So like this needs to be updated. What this lets me do, and I did not come up with this, I think Ben Johnson, the guy who wrote BoltDB, came up with this kind of structure doing stuff, or he took it from somewhere else, I don't know. But it's really nice because you can basically, you set, for the structure, you set properties for the function. So basically closures or whatever for overriding. So you basically have the structure match the interface, and then you define the methods for that interface, and then you call the function. So in your test cases, you can basically slide in, if you want to update just this one method, you basically assign it. So you say, okay, if this test case calls player stats, I'm going to implement this function. It's going to return this for this particular test. So it lets you to easily kind of compose and modify specific behavior. There are mocking libraries that will do a lot of this stuff, but they're just so heavy and they're really ugly to look at. So I prefer, as long as I can, keeping it simple to just this structure. Anyways, where was I? Right, I needed to update state. No, I need to handle connect. Yes. Handle connect function. You know, I'm going to put these at the bottom so I know which ones are new. This is going to be a function that doesn't do anything. And then connection function. That handles that. And then I think, did I add anything else? Character, set character. Oh, it'll tell me. And then I can just do this. Oh, how did I do that? Hold on. Try this again. Shift I and yeah, things are gonna get weird after this point, so we'll stop there. Group ID. All right, so return. We do need to return. So c.group ID function. We don't need a return, so we're just going to do c.handleConnect function on. We are going to return c.connection function with 1 arguments. And I think that should make team happy. Yep. So when it creates its team with players, everything's happy for that. Cool. Channel client test. That was that one. I need to rename that to just clients as well. But anyways, new test. Server test. Go. I'm going to just do the normal internal package because I need to test. I just want to test the internal Go validator stuff because I haven't used that in a while. Test message validation. Team this is equal to use. I never renamed that. Shoot. 1 second. Where's server? F2 server. Actually, I should call this like game server because server.server stutters. All right. So we have server, which I think takes a context background, and I thought it took a matchmaker too. What? Oh, game server. What am I doing? Wait, what? Didn't update that. Everything else did that. New game server, and then matchmaker. I think matchmaker, which also takes like a context. So I'll pass that in, and it needs a session manager. Need a session manager. Cool. Yeah, I already wrote that. Cool. All right, and then matchmaker. All right, we're not going to bother. I just want to test that one method. Process group message. I need a client, so here I can use mock client. ID is 123. I don't have any functional ops. Data. JSON raw message. So I need to test two things here. That's going to give me a network message. New create. Yeah, this is what I want on a group message. Right. And I'm going to set the size to 6. Oh, I don't have any errors. Whatever. I'll figure that out in a second. This is message.group message. Create requested. So it's going to have that message, and it's going to pass that as raw JSON. I think it should, since they're both JSON and raw message, is just data as a byte slice. Yeah, so it's fine. It doesn't like the client though. Cannot use mock client, chain client, value, and argument process. Oh, I need to use the interface, which should be the same, so it should be fine. And that's why I was referencing everything by method. Cool. So that's done. You know what? Just for fun, I'm going to actually return an error. That way I can actually test if this works. Return undeclared name error. Oh. Stop it. Oh, yeah. Oh, I guess you need it. That's weird. I don't know why it was yelling at me. String should not be capitalized. Well, maybe I want to capitalize it. Not whatever. String should not. You stop it. Okay. Server tests. Group message. Do we get an error? The moment of truth. I think we do, because I don't think that struct tag is correct, but I'm just guessing. Build failed. Undefined. You are not wrong, sir. Right. How about now? Undefined validation function 3 on field size recovered undefined validation function. One of, alright, what the heck is this stupid? Oop, didn't mean to take that one. Go validator one of, it's not that. Validate required one of. Yeah, what the hell? Validate a list of values. Oh, there needs to be a space? That's weird. Failed on the one of tag because I said 6, try 3. No map. What? Group ID mock client. Oh, because I never actually. So here's what I was talking about before. So let's say I have this client, and for this particular test, I need to say that the group ID function should do this. It should be. Return 1, 2, 3, 4, 5. So this lets you basically change the way functions or methods work per your test. So let me pass that in. And stop it. Wait, what? Why did I get that message? Process group message, unmarshals, validates the struct, pass that validation. There's a group create request. If the client group ID does not equal, oh, I do want it to equal 0. And there we go, test pass. All right, I think that's enough for today. I went way over what I was expecting, but I'll be back tomorrow, same time. So yeah, hope you enjoyed the stream. Thanks for watching.